Then you're going to notice we're going to 127. If we were going in order, I'll move this. If we were going in order, we've done 124 today. We are skipping a few lessons. So when we're working through this lesson or when you're working through your homework, you identify like, oh crap, I need to work on these skills. I need to go back and review this. Please use your textbook as your resource and go back and review those skills. Some of what we're skipping is how we convert fractions into decimals and decimals into percents, or fractions straight into percents. Because it's assuming that since we're in the accelerated class, we're a little bit better at that. So if you have questions, please ask them as we go. But we are skipping about 3 lessons to get to where we are today. I'll give you another second to get this down. Just like yesterday, I want to be as hands-off as possible unless you ask for my help. So once you get your homework done, once you get everything out, the last thing I'm going to talk to you about is where we want to take notes. Again, I'm learning as we go. We've only had 1 training session on this stuff yet. If you look at your toolkit, you'll notice we yesterday were on page like 10. You know, probability definitions. If you flip one more page, we're on chapter 2. So we do not have much more in chapter 1 here. Okay. So we can, and please do this because this is what I'm going to be expecting when we do the next journal checks. If you flip back to page what is numbered as 2, you'll see these learning logs. We're going to start to use these as your primary locations to take notes. So, and I'm doing this because I think most of us filled up this space on the left-hand side of the probability one. So sorry this is kind of out of focus, but you don't really need to see the focus right now. All I'm trying to get you to see is flip to page 2 in your book, date it, and this is wrong for you guys because this was from the morning. I just don't want to write in here again. Date it. We're doing 127, and then I'll flip over to my smartboard and give you the lesson title. If you don't have the homework down, it is also on the homework board, just written a tiny bit smaller. So today is 9-7, all day long. And we are talking about, sorry, I'm going to do 1.2.7 first. Talking about compound probability. I do have poor handwriting, but sometimes my smartboard is just possessed. So, well, the students who have perished here. We can talk about the ghost later. What do you think compound probability means? We know what probability means, right? The chance of something happening, but compound probability. So what sort of, can you think of a situation where one probability and another probability might like tie to each other? And, I mean, you'd have to have another situation. Now, would the coin affect the other thing? So, let's try one more thing. Ooh, things that correlate with each other. So one thing that I also like doing beyond camping and kayaking is riding my bike. I have a road bike. I want to ride Peloton eventually. That's my goal because my mom had cancer, my niece had leukemia, so it's pretty close to me. If I'm looking at a bike ride on the weekend, I might be like, oh, there's like a 75% chance that I'm going to ride my bike. But then I look at the weather, and I see that there's a 60% chance it's going to rain. You think rain might affect me riding my bike?
Yeah.
So this is what we're talking about when we start dealing with compound probability. So that's all I'm going to say on the topic. I want you guys taking notes in your learning log so that I can collect this if I just want to check notes and not your homework. But again, if you get done with the lesson, you may work on your homework. If you do that, switch to your math journal. All practice work, all homework should be in your math journal. Question, or are you just making shadow puppets? Will, question?
Have you made the backwards bike thing?
No, I need a lot of time. That probably won't happen until Discovery Days, if it ever happens. Because I also want to make a PVC marimba. I have a lot of things that I want to do.
Make the bike first. We can see a video.
Well, I gotta weld. If I do that, I gotta go to my brother's. Alright, so dive in. We are on 127. Oh, it's on the other screen. Sorry, Dan. I do, but he has to have time for me to come over and use his welder. So I'm gonna read our intro paragraph, and then you guys as groups can decide how you approach 119, if you want to read it out loud or whatever. So, compound probability. So far in this section, you've worked with probabilities involving one specific desired outcome. Now we will investigate probabilities of compound events. Compound events are events with combinations of outcomes. In today's lesson, you will find the probability that either one of the events or the other events occur. In Chapter 5, this is what I'm kind of leading you to with the whole rain and bike ride situation. In Chapter 5, we'll consider probability that both one event and another event occur. So what are the chances it doesn't rain and I go on my bike ride? So that would be together. Or that it does rain and I clean my garage, or what, like two different things connected. So think about these questions as we work with our study team. So how is probability related to the probability of a single event? Either what event or what event, or what other event are we interested in? And does our answer make sense? Please have your brain turned on, constantly analyzing, does this make sense? Aside from that, raise your hand if you have a question. Have at it. Anyone have a chore spinner at home? Or like a chore wheel or anything like that? So this is operating under the assumption that Thomas has a chore spinner and his chores are assigned at random. Okay, so this is a spinner that assigns what chore he does. Alright, I'll shut up.
Sections on Thomas also lives in the house by being one chore after school. Each day Thomas and his hand uses the spinner and write to describe which chores he will do. Here's what Thomas knows.
Each day, Thomas and his
On the
aunt
spinner,
spinner
red
at
keys and pointer
right
are the same size.
decide which chores he will do.
Equal in size.
What is what?
Then make up half the spinner.
I mean, if you can share off something, it's okay. Like, if you want to put, like, a book here and a book there, like, you can share books. Yeah, you do need this up. Or you can also look up this, I guess. If you want to be real easy to yourself, you can also look up this.
And vacuum are equal in size together. Make half the spinner. No option. A. What is the
Alright.
probability that Thomas will spin do lunch?
It looks like you're shedding pencils. I itch.
I know.
These pockets aren't really keeping things
I
in.
just
Keep rolling, sorry, you just a pile of pencils.
So then, if clean back is like one.
Awesome. People are numbering this question in your math toolkit in that little left-hand bar there. It's awesome. You want to number this is 119 or 1-119 if you really want to. Yeah. I mean, we know we're in chapter 1, so the first one is not really.
It's 25%.
both of those will bind. And
we split that in half. So vacuum and clean the
That's like
bathroom is
88%.
90%. Plus clean the bedroom is 25%. No.
No.
It's
Because a third.
It's 33.3.
Yeah, so it's like 88.
Yeah. So
I know that one. They're 100 is 33.333.
let's just write down.
So, if this is 50%, add 33.333, so on, and you make 88.333. Right?
80. Then
Yeah.
breaking the.
No. I know, it matches the color.
Wait, Annie. Guys. Then. Can't be 10%. That's just fine. So, raking the leaves and doing the laundry, we don't know how much, but all we know is that both of them combined is 17.7.
Okay, so just split that. Yeah.
Yeah. How to split every decimal in half.
I'm getting it.
Adding percentages. Since we're adding percentages, then look, 80.
Your goal would be to do this without a calculator. We're working with fractions. Now, I'm not saying you can't, but your goal would be to do this without a calculator.
17.
Okay, so 17.7
Mad at it. Okay, so we're dividing. Oh, yeah, this is by 2.
Is it not repeating decimal? Okay, guys, I gotta do it.
Focus.
That's what I'm doing. Yeah. So,
You are welcome to ignore me if you so choose. Annie, have you figured out the amount of spinner contained in this section?
yes.
How?
So we knew that clean bathroom and vacuum was 50% of the spinner.
Okay.
And we knew from previous knowledge that a third of 100 is 33.33333. So we added 50 plus 33.3 and got 88.83.
88?
83.3 repeating decimal.
Okay.
So then now, since 83.3 repeating decimal, if we want to figure out how much in total first. So then doing the laundry and raking the leaves, you just do 100 minus 83.3 decimal 3. So then that, I think we got 17.7 repeating decimal.
I think it'd be 16.7.
Oh,
Because
yeah,
if you had 83 without the 0.3, it'd be 17. So,
and then we're trying to divide that by 2.
And it's that one. Yeah, so repeat.
Hey, give me your eyes for just a second. Sorry, I said you could ignore me, and that was fine, but now I'm going to show you something. So our group over here took the percent route. They immediately converted things into percents. We know that's 25%, 25%. Previous knowledge, a third is 33.3%, repeating forever. They do all this, and they get that this section together, both of those, is 16.7, repeating forever, and then they tried to divide by 2, and they said it's not working. At least not well. Tyler, what alternative do you have?
What my group did was we just rounded basically 16
So, since it's so dangerous, does anybody have a route that does not involve rounding, that may not even involve percents? Mina? They made everything into, what do you mean made them into fractions? They are fractions.
Well, like, we added the clean bathroom to the vacuum. No, the clean bedroom to the vacuum to the clean bathroom.
Okay. How'd you add those?
All the fractions, because vacuum is 1/4 and clean bathroom is 1/4, so it's 2/4 plus 1/3.
So, do I get 3 8/11ths? Which is 4, 4, and 3, right? Rachel, sorry, you've been very patiently waiting with your hand up.
We, because we can't add fractions at different denominators, so we changed them all to the denominators also 12.
Ah!
So if we made it, so we added 4 12s, 3 12s, and 3 12s, and that equals 10 12.
So hold on. So we got to step back over here and say this 1/3 they rewrote as 4/12. How'd you do that?
We knew that 3 goes into 12 4 times. We multiplied
Ah.
that 1 by 4.
So we multiply by 4 here, multiply by 4 here. We get that equivalent fraction. So they took 4/12 plus 3/12 plus 3/12 because these 3/12 came from the 1/4 probability.
And then that equals 10 12. So you have 2 left for 2 spots for each of the 1 12.
So if you have 10/12 taken up by these, and these are equal, each one will be a 12. Now, if you plug a 12th into your calculator and figure out what it is, it's an ugly decimal. Which is why this was not working out very nice, because the decimals make things ugly sometimes. Fractions are better than decimals. This does not mean I like them more. I like decimals better. But fractions are more accurate. They are better to work with if you can. Love your method. Keep rolling, guys. Oh, sorry, the other thing, be careful with B. It says not. I knew that some people would probably miss it. It says not. 0.2 clean back.
Yeah.
But we learned.
Yeah.
So,
As it turns out, if one of them is a repeating decimal, we should just use fractions.
Yes. Yeah. So now all we have to
Figure that out.
B. Thomas hates to clean the bathroom. When he spins the spinner, what is the probability?
Oh, yeah. If you're done, keep moving on.
Clean the bathroom?
Yeah, guys, as you finish problems, keep rolling onward. You do not have to wait for me unless I tell you to.
well, the whole thing is 100, right?
Clean bathroom.
Yeah. And that's it. 25%. This one we can decide this percent.
Because it's early figuring out where
So, no, the whole thing is 100.
right your head belongs.
Yeah, and the answer is 25. Seriously, when I do this, I just throw in my clothes away. I just throw them away. Oh, my dad just wore them.
I was about to say you should donate.
We're making that.
Alex. So if we look at B together, so I'm trying to release you and then bring you back to page and we're a little short on time today. If we look at B, do you know how, and by the way, now that I'm calling with cards, you can always phone a friend to ask for help, which I would say use your teammates first probably, or you can pass if you really don't know, but I'm probably going to then ask you a question about what's giving you an issue, just so I know like where the confusion is. So Alex, do you know how to talk me through how we can figure out a not probability?
So first off, we know that our percentages, it's out of 100%.
Okay.
And we know that clean bathroom and vacuum are the same probability.
Okay.
So we know that clean bathroom is a fourth.
Okay.
And we know that a fourth is 25%.
All right.
So you take the 25% from 100 and you get 75%.
So really what Alex is saying is there's a 100% chance our dude's doing chores. Right? Like he's gonna do a chore. But if we want to look at the percent chance that he won't clean the bathroom, take that probability away. And we end up, and now you could have worked with the fractions. You could say 1 minus 3, or 1 minus 1/4 leaves you with 3/4. But if you work with the percentages, you immediately get to your percent answer of 75%. Now, be careful. When it says probability, and I'll get into this as we get closer to testing, probability is actually the fraction between 0 and 1. Chance is percentages. Now, we do use percentages to talk about probability, but technically it's supposed to be that fraction between 0 and 1. So we would really, to answer this question, say the probability of him not cleaning the bathroom more accurately would be written as 3/4, because we like the fraction form when dealing with probability. Keep going. I'll probably bring us back together one more time before class is over.
Okay, so Thomas is on hopes that he will either spin clean bedrooms or rake leaves. What is P clean room? What is P rake? Probability. What is probability times?
Okay. Wait. Why didn't you just like break the thing? Why doesn't she just say go break the leaves and go clean your room?
What's the order?
So
Add small weight.
so always does. Okay, anyways, what is P probability
Bathroom is 1/3. Why?
Anyway, but that's probability.
What is the probability?
Back all the way up. What's the probability of clean bathroom? At the beginning. 1/4. How do we turn 4 into 12?
What?
Times
Yeah.
So clean bedroom would be 4/12. Clean bathroom is
We already figured out rake leaves.
No, but then again,
You fell in the trap door. Be careful. I hate that the words are so close. Bedroom, bathroom. I wish I could say something
And
else.
the first time you were, the easiest way to do it with practice.
Does it take me coming by here to refocus us? Were we on topic or off topic? You saw me. Okay. We have very limited time. Try to stay on task, okay?
P, is it times that, or are they
That's
talking
probability of cleaning the bedroom. That's probability notation.
But then wouldn't that be probability, like say for cleaning the bedroom is 1/4?
Nah. Cleaning bedroom is 1/3.
I mean, yeah, 1/3. And what would,
Probability of rake leaves is up here.
what would you do 1/3 times 1/3 since it's probability, which is 1/3?
So we're saying or this option or that option, right? So actually, this might be a good time to bring it back together. You can ignore me if you want. When we look at the probability of cleaning the bedroom, I'm going to put this on top of that. Sorry, give me just a second. Bring to the front. Sorry, so this is kind of ugly because I drug this up here. Dragged? Is dragged proper?
Yeah.
I think, yeah, that's one of those things where Mrs. Gordon blows my mind and she's like, yeah, no, it's dragged. Alright, I'm just going to put that on the TV, actually. Alright, up on the TV, we have our chore wheel. Most of us already determined clean bedroom. We looked at it. It was 1/3. Now, Ava, Rachel, Mina, and they were back there having this little debate thing, and they got it all sorted out. But they fell into the common trap door. And I hate that this problem is bedroom, bathroom. They're very, very similar. Be careful. Bathroom's 1/4. Bedroom's 1/3. So when we start with a different denominator, it's going to change what we do. So since clean bedroom is 1/3, to make that common denominator We want twelfths, right? Because we already figured out the probability of raking leaves is 1/12. So to make this a 12, what do we have to multiply by? Anybody? 4. So my numerator becomes 4/12. Now, his aunt wants him to do either of those. If I tell you I have a 1/2 chance of flipping heads and a 1/2 chance of flipping tails, what's the probability I will flip a heads or tails when I flip my coin?
50%.
I said or. I don't care if it's heads or I want either. She doesn't care what chores he does. She wants him to do either of them. So when we don't care what we do, like what the result is, there's 2 possible results. What happens to our probability? Does it go up or down? It goes up. It gets more likely. So somebody posed the question to me, do I multiply these things together? If you multiply 2 fractions, they become smaller. Chill for a second. You're going to look a hole through your forehead. So, when we look at combining the probability for either one, it should get higher. So keep rolling.
So, what is 1/12? We just have 4/12.
Right? No. She wants him to either clean the bedroom or rake the leaves. Clean the bedroom is 4.
Ooh, don't go to decimals.
Is what.
You have fractions, right?
So
If I give you, like, so say we order pizza and Domino's, and we've got 3 different kinds of pizzas, but at the end of the night, we've got 3 slices left here, 2 slices left here, and 1 slice left here.
rake the leaves.
If all the pizzas were largest to start, they'd all have been cut into 8 pieces. So that 3, 2, and 1, can I put those in the same box? So if I have 3, 2, and 1, how many slices do I have now?
What is the probability?
Man, I get so excited about
6 out of an 8. Now if they're together in one box, so the denominator stays, the numerator.
No, I'm so excited about that.
You don't have to go to decimals. Fractions are better.
First question is what is the probability of the clean bedroom? What is the probability of raking? B is what is the probability that he will spin either one of those
So, I already won. Okay. A is right here, and B is.
How can you write the 2 outcomes as single probability?
If you're struggling, I threw an equation up there that you could write the other way around. The probability of either will be the sum of their 2 probabilities. So when we go to do this, Tyler and I just talked this out. What do we need to add together, Tyler?
We need to add the 4 12s and 1 12 equal 5 12s, which then will be close to 40.
So one thing that you guys need to learn about me is I love pizza. I can make you pretty much any kind of pizza, like not Italian or whatever. I was at Pies and Pints last night eating a Chipotle chicken pizza. Think about it like this. If we order 3 large pizzas, pepperoni, sausage, mushroom, whatever, don't argue about toppings. I have 3 pepperoni slices left over, 2 sausage slices left over, and 1 mushroom slice left over. I don't know who ate all the mushroom. But I can put them all into one box now. Right, so I had 3, 2, and 1. I have 6 slices left over. But the size of the slices are all the same. If we order from Domino's, a large pizza has 8 slices. Each slice is an 1/8. Each, like if we cut the wheel into equal sized pieces, we'd have 12 pieces. Bedroom gets 4 of the pieces. Raking leaves gets 1 of the pieces. If I don't care which one I do, I have 5 possible options to choose from, still out of 12. Another mistake people make is they try to combine denominators. To add or subtract, they got to start the same, they got to stay the same. Well, I'm sorry. All right, welcome to math class. You're going to end up hungry. Yes.
Can we, if we run our room here, can we go right
Yeah, we're going to fill the learning log section. We're almost done with chapter 1. Actually, we only have 1 more lesson in chapter 1 with you guys.
How can
All right,
you
keep
rate
going.
the
I'm
two
like, bring us back
outcomes-
together in about 2 minutes.
How can you rate the 2 outcomes as a single probability?
I do not like
What?
mushroom cake extra. But keep working on that. We can talk later.
I already did that. So now we're on 121, right?
Yes.
can you write the two outcomes as a single program? Yeah. It's just like, well,
Yeah, but
Stewart?
Oh,
Oh,
no, we're not.
no, it's like
borrow pens and
Yuan
pencils
or
or
something. It's Japanese. Actually, we could get Mrs. Pullman.
and mechanical pencils and blue pencils.
Is that all the hundreds of pencils, pens, and mechanical pencils? There you go. You have your retirement. You realize they're $10 for like.
Say, in 121, nobody has taken anything out of the bag. This is, as I read through this, I assumed it would confuse some people. She tells him. So she gives him data. That's theoretical, right? Nobody's done anything until Stewart reaches into the bag. So I assumed that would confuse some people. Like, wait, if they already took things out of the bag, nobody's taking anything out of the bag. But she tells him with probabilities.
Okay. So 2 out of every 5. So. About a mechanical pencil.
No, it's the 7th, you idiot.
All right, we have about a minute left, so I want you guys to have a conversation with me while you start to pack up. I know we did not really get done with this lesson. Tomorrow, I will not be here. I'm not sick, no doctor's appointment. Like, I do have a doctor's appointment in January. I'll warn you guys about that. But tomorrow I won't be here because I will be out observing exemplary teachers in the Worthington District. It's an initiative that we're doing, part of our building leadership team, to help make us better. We want to go watch teachers that have mastered the craft in a way. So, either Mrs. Cullinan, since she doesn't teach on Fridays, or Mr. Sherd, since he doesn't teach at all, will be your teacher tomorrow. I'm trying to figure out what to do, and here's what I'm thinking right now. So hear me out, give me feedback, we'll do a thumb first, and I'll take verbal if you want. My idea is to just have you guys, same groups, continue working this lesson, finish 121, try to get 22 and 23 done, and then, that's the end of the lesson. I would just give you the rest of the class time tomorrow to work on those homework assignments. The 27 or 24 through 27 and 37 through 41. How does that sound if that's your objectives for tomorrow? Finish today's lesson and then just use the rest of the time for teamwork on the practice. That makes sense? Will you guys remember to switch over to your math journal when you start doing the homework?
Yeah.
Okay, so here's my question. I subbed for 6 months. It's terrible to sub for a class when the notes say, oh, just let them work. Because it always falls apart. Kids are off task. They're talking about what they're doing this weekend. Will you guys stay on task if I leave it kind of open to you guys using the work time? Can I trust you guys?
Yeah.
Okay, so this is our first shot at me not being here to teach your class. It's still going to be a Phoenix teacher, which is good. Makes me trust it a bit more. But I got to trust that you guys can stay on task. You have every opportunity to go into the weekend with no homework. So that's what we're going to do tomorrow for class. You might want to talk with your team right now about, okay, what problems do we want to try to get done tonight? What do we want to work on together tomorrow? So that might be a quick conversation we have, May. Monday, Tuesday. Yeah. So, like, the 27th, or 24th, 27th, 37th,
Yeah,
I'll take both days in box. So tomorrow is just going to say same for homework. Yeah. But if it's Friday's homework, it's not due on Monday. Right? I give you 2 business days, so it's really due on Tuesday. What's up? Why are you showing me?
Oh, you're not done. Okay.
No, some lessons we just like, there's certain questions we need to get to and other ones that we get to a grade if we don't. Or was this from home? No, this was lesson work. Yeah, we're fine. Have a great day, guys.
Thank you.
You are out here on to block 2.